This video will talk about classifying soils using soil taxonomy. Soils are classified using many different properties. The classification that we are using in this video is known as soil taxonomy. Some of the properties that soils are classified by include soil temperature, soil moisture, profile characteristics, presence or absence of special horizons, and presence or absence of other soil properties. Soil taxonomy starts with soil orders. There are 12 soil orders. Soil orders are based on the soil forming process. Soil orders include soils with properties resulting from similar soil forming processes. A soil order is the most general category. Soil orders are divided into suborders. There are 54 suborders. Suborders are divided based on differences in soil moisture, soil temperature, and soil chemical or textural properties. Suborders are divided into grade groups. There are more than 240 grade groups. Grade groups look at diagnostic horizons. Soils in the same grade group have the same kind of soil horizon arrangement. Grade groups are further divided into subgroups. There are more than 1,300 subgroups. Subgroups are divided into types. There are 3 types: typic, intergrades, and characteristics. Subgroups are further divided into families. There are more than 8,000 soil families. Soil families are based on properties important for plants or engineering purposes. Lastly, families are divided into series. There are more than 23,000 soil series worldwide. Soil series is the most specific unit of soil classification. It is based on the arrangements and types of horizons. There are more than 19,000 soil series in the United States alone. The first soil order we are going to look at are entosols. Entosols are soils without developed horizons. You can't see the horizon very well in entosols. They are typically light colored and are young soils. They have often develop on steep slopes and can occur in any climate. 8% of the United States and world soils are entosols. The next soil order being discussed is inceptisols. Inceptisols are weakly developed soils but are more developed than entosols. They are prone to erosion and tend to form on top of weathering rock. 18% of the United States soils and 9% of world soils are inceptisols. Inceptisols have a poorly developed surface horizon. Andesols are formed from volcanic ash. Andesols are dark, organic, and fertile soils. They form in humid climates and are found in many locations but are not common. Andesols are high in metals, especially iron and aluminum, and andesols are typically young soils. Gelosols are formed where permafrost is always present. So permafrost is when the ground remains below 0 degrees continually. Gelosols form in tundra regions, and gelosols can be a mineral or organic soil. However, gelosols do show cryoturbation or cold disturbance. The next soil being discussed is histosols. Histosols tend to be an organic soil and form under wet or cold conditions. Histosols have a spongy texture and are the least common soil order. Histosols tend to be dark in color and very lightweight when dry. However, they do have a very high water holding capacity. Next are aridosols. Aridosols are found in areas where it is dry for more than 6 months of the year, so typically deserts. There's an accumulation of calcium carbonate and salts. Aridosols are very productive when irrigated and are the second most common soil order in the world. Next is fertisols. Fertisols shrink when dry and swell when wet. This is because there's a lot of clay. Vertisols have more than 30% clay. They are very fertile, but are difficult to cultivate due to the clay content. They are also unstable for engineering. Next are mollisols. Mollisols have dark surface horizons and are usually under grasslands or hardwood forest. They are highly fertile and rich in organic matter. Mollisols are the most common soil order in the United States. Alphasols are well-developed soils. They are fertile and are the most naturally productive soil. Alphasols are the second most common order in the United States. Ultisols occur in warm, humid climates. They are highly leached and are red or dark red in color. They are acidic soil and require lime to balance acidity and be productive. Next is spodosol. Spodosols are sandy soils occurring in high rainfall areas. They are highly leached and very acidic. They usually occur under conifer forest. Spodosols need fertilization and lime to be productive. Last, we are going to look at oxasols. Oxasols are the most highly weathered soils. They are formed in humid tropical or subtropical climates. They are yellow or red in color and are acidic. They have high clay content and are low in plant nutrients. However, some crops are grown productively on oxasols.